Hi everyone, welcome to the Unhandled Exception podcast. I'm Dan Clark and this is episode number 18. And today I am joined by Stefan Pölz to talk all about mutation testing. Now, I've been really looking forward to this episode since November last year when I saw Stefan's lightning talk at .NET Southwest user group. So that's not .NET Oxford that I run, it's a fellow user group in Bristol, I believe that is, but this was virtual obviously. And I'd heard the term mutation testing before, but didn't know what it was. And Stefan's talk explained it so well and it sounded super interesting. And I remember thinking at the time, I need to get him on the show. And 7 months later, here he is. So welcome to the show, Stefan.
Woohoo! Thank you much for having me. I am super excited to be here today.
Oh, that's quite all right. As I say, I've been looking forward to it since November 2020. I think a lot of people have wiped that year from their memory, but I've certainly not forgotten that talk. It was fascinating. In fact, it was funny. I remember in episode 15 where we had Jason Bock on, and at the end we got chatting about different kinds of testing. And I mentioned mutation testing in your lightning talk. I said it at the time on the show, I really wanted to get you on the show and was planning to ask you. But at the time I hadn't mentioned it to you. And a couple of weeks later, I did ping you to see if you were up for it. And you said you'd been expecting me to get in touch because you had heard it on the show. So I didn't actually know you were a listener, so that would have been really embarrassing if I'd actually forgotten to reach out to you. But
this was so surreal because you mentioned me, and I was kind of anticipating a message.
Well, I'm glad I remembered. But when I listened to your lightning talk, I thought it would make such a great episode. So it's great to have you on.
Thank you for your kind words.
No problem. So before we move on to mutation testing, I'm going to give a quick listener mention. And this episode's mention goes to Adam Storr, who said on Twitter, another great Unhandled Exception podcast with iCooper. Really interesting and can relate to some of it. Worth a listen. Thanks, iCooper and Drakan. So iCooper's Ian Cooper and Drakan is me. And he's put a link to episode 17 where I was joined by Ian Cooper talking all about TDD. So thanks for the mention, Adam. And if anyone else wants to get mentioned on the show, use the hashtag #UnhandledException on your social media platform of choice. So mutation testing, it's a great name and it sounds awesome. It certainly sounds much more exciting than unit testing or integration testing. So what is this mutation testing all about then?
So mutation testing is a sort of brute force approach to test the effectiveness of our test suite. So what it does, the tool analyzes our production code and tries to find expressions and statements which can be mutated. For example, changing an addition to a subtraction, or perhaps also with link methods, changing a single to a single or default. And every small modification is called a mutant. Each and every mutant we run our test suite against. Perhaps not the entire test suite because that may be quite big, but at least the impacted tests. The impacted tests are those which are actually covering this line of code where the mutant has been generated. And when executing those impacted tests, we now expect one test to fail, or at least one test to fail. This is now when a failing test is good, because it tells us that we not only cover this line of code, but also have an assertion statement in our test code in place, which expects the production code to be in a certain way. And if we then have, for this mutant, a failing test, that means that the mutant was killed. If we do not have a failing test, then the mutant survives. Now, this could be because we don't have an assertion statement in place, or perhaps this code isn't even covered. And at the end, we then receive a report which contains a percentage of the killed mutants and lists all survived mutants. And this then gives us, in addition to code coverage, it's an additional metric to measure the effectiveness of our test suite. We then have to inspect this and evaluate this report. And it basically tells us two things. The primary thing is it tells us which of our production code is both covered and asserted by at least one unit test. And the secondary result would be we could discover that we have some dead code in place. So code which isn't executed, or maybe code which is executed but doesn't really contribute to the state of the code.
So where I've sometimes done TDD, test-driven development, and sometimes done test after, written the test after, I noticed a massive difference in the fact that when I'm writing test after, I think there's lots of scenarios where if I just went into my code and deleted a line, I would be pretty confident that a test probably wouldn't break if I'm trying to do test after code. And that's where I really see the benefit of TDD, is just making sure I've got that code coverage. And this just sounds perfect to actually capture that.
It is. So it's an additional tool which helps us prove that our tests are good, and we can give this confidence to the test suite and actually just push to production.
So just to make sure I'm understanding it properly, so some library or the mutation testing framework in memory is going to just randomly change your code, maybe swap lines around, delete a line, change an equals for a not equals or something. And then every time it makes a change, it expects a test to fail because your code has changed. So it's testing that test is covering that logic. And then if this test doesn't fail, the mutant survives to the next level, and you're almost gamifying it because you've got to kill those mutants effectively. Have I understood that correctly?
Yes, indeed. So for every surviving mutants, now we have to figure out why this mutant has survived. Is it perhaps not covered? Is there perhaps an assertion statement in place? Or is this piece of code, is this, for example, a null check? Is it even necessary? Does it contribute to the flow? And then either improve the existing test, add an entire new test, or perhaps delete this line of code altogether.
Because to me, this sounds just so much more useful than the normal code coverage you get. It's real code coverage, isn't it? Almost.
I wouldn't say it's better or it's different. The benefit about code coverage is it's super quick. We can do, for example, if we're in Visual Studio, the Enterprise Edition has live testing, or with the nCrunch plugin, or Wider also has inbox the continuous testing, and this is super quick. So for example, on every save, we can run all impacted tests and then see to the left in the gutter immediately, okay, this line is covered and is failing or is passing. So that's super quick. Mutation testing is not so quick because, first of all, we have to scan our code, discover the mutants, and then actually run the tests a lot of times depending on the amount of mutants found. For example, I have a smaller Roslyn analyzer project. We have there roughly 70, 80 mutants. And the entire test run, or the mutation test run, takes 15 minutes on a CI build. So it is a good addition to code coverage. It doesn't replace it. And could also discover or unmask coverage only tests. In one company where I was, we had this gated rule that we need at least 80%, I believe, code coverage. And in this code base, some developer may have sneaked in some coverage only tests where there isn't a meaningful assertion, and such tests would be unmasked.
Yeah, you can picture developers writing tests and forgetting to put any asserts in, and then that classing as code coverage, I guess.
Yeah, so code coverage may say, okay, it's covered, it's cool, but there may not be an assertion. So now the more of a brute force approach of mutation testing could discover such errors.
Very cool. So you mentioned LINQ earlier as well. It sounds like the mutation testing library has to have a very good understanding of the language you're using, whether it's .NET, JavaScript, or whatever language it is.
Indeed, yeah. For example, the simpler ones, as you mentioned, would be like additions, subtractions, changing an addition to a subtraction, changing a multiplication to a division, changing the equals to a not equal. So basically, just adding an exclamation mark, or perhaps with pattern matching, changing a is null to is not null. So that's on a language level. Yeah, but the tool also could use well-known BCL library features and change method calls, or perhaps could also discover that a method which has default arguments is called with these default arguments and then replaces them with something else to generate mutants out of our production code.
I would be so scared to run this against some of my projects. Which actually brings up a good question. How does this work with existing projects if you wanted to implement this? Because you mentioned about performance. Would you use this on against libraries and smaller projects or greenfield projects maybe?
I guess as a start, because it's not the most simplest concept, and as a start, I definitely suggest to start with a smaller library. And the more general purpose the library is, the simpler it is to me to actually make meaning out of the mutation coverage report. So yeah, start small. And at the beginning, I also was scared to write against, but it gave me a lot of insight about the code. For example, for me, I started roughly with mutation testing. I also started with building Roslyn analyzers. So this API, the Roslyn API concept is also super new to me, and it helped me discover and understand the Roslyn APIs and the errors I was doing regarding to asserting what I wrote there, because I did a lot of trial and error and didn't have 100% test-driven development in the beginning. So this really helps. And perhaps with a bigger project, there may be a lot of mutants, and this may take a lot of time to really go through all of them and evaluate if there actually is something we can act on and improve our either test code or production code. But the mutation testing tools could also be configured to not mutate the entire production library, but perhaps just some parts of it. Maybe let's start with one namespace, or maybe even one file, and then continuously expand this tool until we have the entire project mutation tested.
That's really nice, actually, if you can just start at one file and then build up. I can picture that enabling me to start using it much sooner than I would normally do if I can do that. How does this know when to stop? Because if I think about a code base and all the different combinations of operators, of methods that could be deleted or like lines swapped around, there's an infinite amount. How does it know when to stop changing things and the test run has finished?
So the first step is discovering all the mutants, and now this depends heavily on what the tool considers worthy of being mutated. We previously mentioned some smaller, very expression-based mutations, but mutation testing technically could also remove entire bodies or change a while loop to something which only executes once or not at all. And yeah, there could be a lot of mutants, but depending on the tool, maybe just doing every mutation which is possible doesn't really gain much more benefit out of that. So we're hitting some diminishing return limit, and it's up to the tool to decide what's worthy of mutating.
Nice. Looking through we've obviously got a shared Google Docs, which we were dumping notes into. And I saw the project you mentioned earlier you were doing. You'd shared an Azure Pipelines link to a build, and I had a quick look at that. And I can see the mutation report tab. And this looks really cool. I can see code and inline, almost tooltips showing which mutants survived and which ones were killed.
This is the mutation test report from striker.net.
Yes, yeah.
And I really like this tool, and I really like this HTML report because that's very visual. You see every mutant, and you can then click the mutant and see what the production code was changed into. So this really helps inspecting possible survivors and then set action how to deal with them.
Yeah, I can see you've got a table, how many mutants have survived, how many have been killed, and then, just drilling into the different files. And I can see that a true has been changed to false and various other bits that it's done. This is just a Azure Pipelines extension, is it?
Yes, so the tool striker.net, they also built a Azure Pipelines extension that you install and then can put your HTML mutation report to.
I guess I kind of jumped the boat here by mentioning this because we've not actually mentioned toolings for, I think this is the first time we're mentioning Striker.net. So maybe we take a step back and is Striker.net the tool you would use if you want to do mutation testing for .net?
Yes, because when I stumbled upon it a year ago, I discovered that this is available as a .NET tool. And the year ago, I started really discovering kind of obsessing myself with CI pipelines and played around with Azure DevOps and played around with GitHub Actions. And I then tried to use every tool I've found. And I really like the concept of .NET tools because I can have them as local tools, and then they're part of my repository. And if I run the tool locally, it's the same version as I then can run in the CI pipeline. And this is why I kind of stuck with Striker. I also had a look at other projects. There's, for example, the very first project. Now, back some years, when I was in Germany, a very good friend initially, actually, that was around 2013, told me about mutation testing. But back then, I didn't really care about it. I didn't really understand it. Why do I need this? And there was this tool available, Ninja Turtles. So that name kind of stuck with me. So now, 7 years later, when I reiterated this, I stumbled upon this tool again. But this is a bit outdated. It only works with .NET Framework. And there's a lot of mutation testing tools on GitHub, but most of them are not as maintained as Striker.net is. There is also Faultify, and the last commit is also quite recently, I believe. And this has a bit of a different approach because Striker.net does source level, changes the source code, and Faultify, I believe, does mutations on a bytecode level. Where the benefit is, this is much quicker, but the drawback is that it is tougher to present a meaningful or an easy to read report to the user to actually display the source line of code which was changed.
I suppose depending on how much faster it is, I'm thinking back to the last episode with Ian Cooper where he was describing TDD, and he was talking about the concept of with TDD, because you're writing the tests as you're developing them, if a test fails, you know what failed because it was the last change you made. And I guess if this is quick enough, then if something fails, then I suppose, I don't know whether it's the same as normal testing, because where your unit tests are quite deterministic, so if your tests suddenly start failing, it probably will be the last change you made to the code. If a mutation test passes, is it always going to pass until you make a change in code?
Usually, yes, because the tool would create the same mutants again, so the result should be the same. Mutation testing doesn't eliminate test-driven development because the tight TDD loop of writing a failing test and then writing production code, this seconds in between, that's quite quick and quite undefeatable. And mutation testing is a more thorough insight which takes up to many minutes.
And you mentioned tools like Rider before. I'm assuming that there's no extensions or anything, and it would be like is it a command line driven thing that would be running if you wanted to do a text execution, or is there any extension for things like Rider where you can get some native integration?
I haven't discovered any extension for Rider. There is an extension for Visual Studio called Textura, which is also available as a Visual Studio plugin. I gave it a try, but it didn't really fit my style. I need something which I can also execute in the CI and also make it part of the repository so that every team member then can benefit from this without doing a lot of manual steps.
Yeah, and I guess you could, if you're using PRs or you've got different levels of testing, then you can do a full run on some of the builds, but not all of them. Is there a concept of like a quicker build? I think in your notes you mentioned the difference between a diff test run and a full test run.
In the open source project that I currently have, I didn't really had to use it yet. Well, I start to think about it now. So as the solution grows and the full mutation test run just takes longer and longer, I now start to consider actually doing only the diff on a PR. So there are only mutants generated for the source code, which I've actually changed in this pull request. And then on every push to main, there should be a full one just to be sure.
If some of the mutations that are made are, like, for example, swapping two lines around, I don't know if that is one of the mutations it does, But if swapping those two lines around shouldn't really make a test fail anyway, just say that it didn't matter what order. There were two function calls and it didn't matter what order they were made in. Is there any way to tell the testing framework that that's okay?
That depends on the tool, but in general, yes, there are most likely some configuration in place how I can tell the tool what to mutate and what false positives to ignore. The example that always pops in my head is I recently started using debug assert a lot, and I use it most of the times to debug assert that something is null or is not null when I'm sure, okay, this cannot be null here, but the null flow analysis of reference types, static analysis, can figure it out at this given location, then I can give a hint with that. But yeah, they're only, under air quotes, only debug asserts, so mutating them doesn't really make sense or add value. So I always tell the tool to, okay, do not mutate the debug.assert method, or likewise the configure await false or configure await true. I never have a test in place which fails if I change configure await false to true, so I always exclude them as well. So it depends then heavily on the project how to configure the tool to get a meaningful result which contains little to no noise.
Very cool. So are there any major issues you found whilst doing mutation testing?
So what I found is that it really depends on both the production code that you have in place. This needs to contain mutable statements or mutable statements that the tool is aware of, and also in general the mutants that the tool supports. For example, we have switched one project from C#8 to C#9 and then used all the glorious new C#9 features. I'm kind of a sucker to use all the latest language features. And just by changing, for example, the null checks to use is not null. And we then kind of lost, I believe, roughly 20% of the mutants which were found because the tool didn't support at that time the is not null pattern matching yet. So yeah, it depends on the production code and the tool to generate the mutants actually.
Yeah, it does sound like whichever library you choose, that it needs to be well maintained if it's got to keep up to date with the languages, especially .NET with the speed they're iterating now. I think they've said that they're aiming to put the C# new releases, so C# 10 and 11 and 12, on a cadence with the .NET releases, so each year now, I think. So it'd be interesting to see how that goes. I'm like you and a sucker for the new language features. I think my favorite is record types in C#9. I've gone through changing all my GTOs to record types, and it's just so much cleaner.
Yeah, and I really do like the init-only properties, and I can't wait for C#10 to also support the required properties. So we could then get rid of some constructors and have really nice null-aware contracts.
So this isn't like me at all, but I've actually not done any reading on C#10 yet. Can you go into a bit more detail on what that is, that feature you mentioned?
So for properties, we can add the required keyword to properties, which then the compiler then enforces that this property is initialized either via a constructor or via an object initializer. And we could, for example, then set our properties to init only, and then for contract types don't really need a constructor, because we could still via the required keyword then enforce those properties to be set during object initialization. I also like it, like the combination with nullable reference types, because currently we always have to add constructors, and that's kind of painful. So this will be nice. Yeah.
Yeah, nice. Do you ever get pushback when you're working with other developers where maybe they don't like using new language features and you're trying to use them everywhere?
So far not, but maybe they are just not voicing it.
I absolutely love all these. I'm very much a advocate of keeping code as simple as possible and as succinct as possible. And I know sometimes you can go overboard with the new language features and things be completely unreadable. But as long as you keep it readable, I'm definitely a fan of keeping things nice and succinct.
Especially with property pattern matching. Yeah, I saw some some crazy stuff out there.
Yeah, you can take it too far. That's why I wanted to make sure that I said the readable bit. But yeah, I think was it the Jason Bock episode where we were talking about this, and there's maybe one of the .NET team. He did mention someone's name.
Something, yeah, and then it was about performance. No, not something with system text JSON. If something is faster than the other thing, I can't recall.
I definitely saw a Twitter thread where it was almost like people were trying to use the new language syntax, C#9 language syntax, to make long sentences just as a joke. Just what code can we write that will compile? And that was quite funny. I'll have to dig it up. Shall we do dev tips?
Yes, dev tips.
Dev tips. Do you want to go first?
Okay, yes. So my dev tip is to enable warnings as errors. So when I saw the video of the QuakeCon 2011, where John Carmack gave the keynote about where he and his team enabled warnings as errors, and having a lot of static analysis in place gave him a whole new insight about the production code in place. And then I thought to myself, well, if the programming legend John Carmack is doing it, perhaps I should also give it a try. And especially now with the .NET 5 contains in the SDK already a lot of code analysis, which is enabled per default. Not all the rules, there's only a selected set of rules enabled, but in the CS Proj you can enable all available analyzers per default. And then also I really like to enable warnings as errors, because this just gives me so much insight about what I'm potentially doing wrong. And I like to do the warnings as errors only in the release mode. So during debugging locally, or in writing code in debug mode locally, I can do some quick prototyping and actually have a nice TDD cycle in place. But then the CI should fail if there's any warning, or then any warning as error, because I always start to dislike a project when I open it up and then there is more than just a handful of warnings jumping into my face.
Yeah, I completely agree. I try and turn that on for all projects too, because it's the whole broken glass syndrome, isn't it? Where if there's a few warnings, then you're not that worried about adding more because you just don't notice them. And then if some of the warnings could actually stop you from having a bug, you're not going to see them because there's just so much noise. And yeah, so just having no warnings. I'm probably a bit, like you mentioned, analyzers, where I would probably start adding rules to enforce consistency in code. And I know this is quite a controversial thing to how much you enforce these things, but I think you mentioned that .NET 5 has them built in. And I think if you're using earlier versions, that it is just a case of adding a NuGet package, and then you have all those analyzers. But yeah, it's quite powerful. And I think there's as well as warnings as errors, I can't remember. In fact, let me just load up a project so I can find out what it's called. I was just going to say there is an attribute which forces the build to fail, as in the Roslyn analyzer builds to fail. Here we are. Enforce code style.
Then just code style, yeah.
Code style in build. Is that the one?
Yeah. So this would be the code style rule set.
Yes.
And
yeah.
not the code quality rule set.
Yeah, so I thought it was just all the analyzers, but the whole code style is maybe a bit controversial. But like the code quality, that's kind of...
Yes, it is. Yes, it is.
I hit quite an interesting problem because I was trying to recently add code analyzers to one of my projects, and I was trying to get the unused using statements. I wanted that to be an error, or at least a more in-your-face warning if there was unused using statements, because I see that quite a lot in projects where I find that Rider's quite in-your-face, but when developers are using other IDEs, then I see unused using statements all over the place. So I was trying to get one of the built-in analyzers to work on the command line, not just on the IDE. I wanted it as part of CI/CD pipeline to be doing the warnings too. And I was struggling to get this to work, so I asked on Twitter, and I got a reply from David Wenger, who's actually a dev on the Roslyn IDE team at Microsoft. And it turns out that you need to add the attribute to your CS project to generate the XML documentation. So it's just generate documentation file. So that's a bit of an edge case, but adding that seemed to get it to work. these analyzers are still quite new, I think, a lot of, especially the built-in ones.
I think they're a combination of FXCop, of the former FXCop and StyleCop.
Yeah, so I tried using StyleCop and I found it very, very opinionated in a old-fashioned way. Yeah, maybe old-fashioned is the right word. It's kind of it was things like where I think a lot of modern IDs, or maybe this is just a rider thing, but it defaults to recommending things like using underscore for private fields and stuff, and that's the default. Where StyleCop was defaulting to this dot, and there was also it was defaulting to recommending that the using statements go inside the namespace, which I found quite strange, and I've never seen .NET code that does that.
Me neither. Somebody explained it to me once why this is better, and at that time I was convinced that it actually is better, but I again forgot about it and fell back to my usual outside of the namespace.
As soon as I saw those, I thought, no, I'm going to find other analyzers. So I started looking into the default built-in ones. I also found there's quite a nice project called Roslinator. I don't know whether you've heard of it. And
yes, I did.
That's got quite a lot of rules, which works quite nicely. So I've been looking at that as well. But yeah, it's all quite interesting. I think especially when you've got maybe open source projects where you want to enforce a consistent style and quality, or a big team where you've got maybe a high turnover of staff, maybe like contractors are coming in and stuff. So just to enforce the code quality and consistency, I think that's really nice. And if it prevents bugs, if it can help prevent bugs. So I'm definitely with you on the warnings as hours dev tip. So after all that, my dev tip is going to be super boring and simple, but it's just a little tip which is a bit of an annoyance if you're a Windows user, Windows Explorer. If you ever tried creating a file in Windows Explorer that starts with a period, so for example, .gitignore, .dockerignore, and this kind of thing, Windows Explorer will not let you do it. So you end up cursing out loud and then loading up VS Code or a terminal and having to create the file there. And to be honest, most of the time, those places are where I would be creating the file anyway. But sometimes I'm in Windows Explorer and I just want to create a .gitignore file or something. And it turns out that if you call the file in Windows Explorer .gitignore dot, so you end it with a dot and press enter, then it works, and Windows will just remove that dot for you. So to create a .gitignore file, just call it .gitignore dot, and then that works. It's a bit of a weird hack, but it seems to work.
We should have met earlier. This could have saved me some pain. Actually, not tried it out right now. I haven't done this in ages because, I always use now, if I want to create a dot file, I use Visual Studio Code now. This is just how it is because that works. I just tried it out and it seems to work now. Was this changed in a recent update?
Oh, without the... Okay. So my dev tip is defunct, I guess. Let me just try.
So I still get the warning about changing the file extension, but it seems to work now.
.gitignore. Oh, okay. So my dev tip is completely defunct. So to our listeners, this dev tip only applies if you haven't updated your Windows 10 or you're using an older version of Windows. I don't know if I should think of another dev tip now after that.
I hope I didn't... Was this bad now? I don't know.
No, I'm glad you said that. It's kind of fun trying to think of... Well, my using statement, code analyzer using statement thing that David Wagner mentioned, that can be my dev tip then. Let's do that. So before we wrap up, do you have anything else you'd like to mention?
Yes, I do. I wanted to thank you very, very much for granting me this opportunity to be here. Because what I now, since the last year and the pandemic, there is now a lot of content online available. And now I really got aware of there is a lot of people putting a lot of effort into open source projects, into meetups, into podcasts. And it is amazing. When preparing for a session, I learned so much about the topic, and I value every opportunity to give something back to the community, of which I take so much of. And it seems to be a fair deal. So thank you very much for inviting me to this show.
Oh, you're more than welcome. Thank you so much for joining me. As I say, I've been wanting to have this episode since I saw your amazing lightning talk at .NET Southwest. And yes, I think 7 months later. 7 months later, we're here. I love doing these podcast episodes because it just means that I get to speak to lots of amazing people. And to me, it's not work at all. It's fun. So, but thank you very much for your kind comments.
You're welcome, and thank you very much for having me.
So where's the best place for people to find you?
So I guess the first start would be to send me a message via Twitter. There I go by 0x_F0, and perhaps also in the .NET Oxford Slack channel. And perhaps if you want to check out the original talk that I gave a month ago, there's a GitHub repo that we can link up in the show notes if you want to test mutation testing out yourself.
And I can definitely include a link to all those in the show note. So thank you so much for joining. It's been absolutely amazing having you on.
This was fun. Thank you very much. And thank you to the listeners for tuning in. And if you got some feedback, I would welcome it.
And also a quick reminder that this podcast is sponsored by Everstack, which is my own company providing software development and consultation services. For more information, visit everstack.com. And if you enjoy this podcast, please do help me spread the word on social media. I normally use the hashtag #unhandledexception, and I can be found on Twitter @Drakan, and my DMs are open. And my blog, danclark.com, has links to all my social stuff too. And we will definitely include all the links we've mentioned in the show notes, which can be found on unhandledexceptionpodcast.com.